The story begins on a quiet night, the kind of night where the sky feels deeper than usual, like it's holding its breath. Across the world, telescopes turn toward a single, wandering object drifting through the dark. An object with a strange name, 3I/Atlas. To the scientists watching from their lonely observatories, it looks calm, predictable, harmless. Just another interstellar visitor passing through the solar system, nothing more. For months, they've been tracking it as it moves closer to the sun, waiting for the moment it reaches perihelion, the point where its light should bloom and flare, like every comet before it. But something happens before the moment even arrives, something none of them expect. The first light curve, the simple graph that shows how bright the object is, comes back wrong. Not broken, not messy, just wrong. Instead of a clean climb in brightness, the curve dips, a sudden drop, like a heartbeat skipping in the dark. And in that small dip, the mystery begins. At first, the astronomers blame their machines. Maybe the sensor glitched. Maybe a cloud passed over. Maybe someone didn't calibrate something correctly. Because comets don't do this. They don't dim before they brighten. They don't bend the pattern of their own light. But then the data repeats. Another dip. Same shape, same timing, same quiet strangeness. And suddenly, every observatory watching 3I/Atlas feels the same cold whisper of confusion. Something inside the object moved. Now, here's the thing about astronomers. They don't panic. They don't jump to wild ideas. Their world is built on patterns, numbers, predictions. But that one dip, that one strange moment, it doesn't fit anywhere. Hours turn into long, tense nights as scientists gather around screens, running the data again and again. And every time they do, the dip stays. Solid, real, unexplainable. Imagine looking at a shadow and watching the shadow flinch. That's what this feels like. To the teams watching closely, it's not just a drop in light. It looks deliberate, like the object turned something toward them or away from them. And that's when the questions start. What force could do that? What could shift the light coming off a comet before it even reaches the sun? How can something so far away already be changing in ways we've never seen? But the biggest question hangs over the room like a silent weight. What if this isn't a normal comet at all? They don't say it out loud yet, but the thought is there, floating beneath the surface of every discussion. Because comets don't change their brightness like this. Not in smooth, deliberate dips. Not before heating. Not before sunlight touches the surface. Something is different. Something is responding early. As the object drifts closer to the inner solar system, it continues its slow, ghost-like dance across the stars. But now the world watches it differently. Every new image is checked twice. Every graph is measured with a little more caution. Every scientist feels that strange electric tension, the feeling that the universe is about to reveal something, and they aren't ready for it. One astronomer later describes the moment like this. It felt like the object was aware that we were watching. Of course, that sounds impossible, and maybe it is. But when data does something you can't explain, your mind naturally reaches for ideas you normally push away. Meanwhile, the public begins to hear small rumors, tiny mentions on forums. Someone posts a blurry screenshot of the unusual light curve. Another person claims an engineer at their lab said the object blinked. People laugh it off at first. But curiosity spreads fast. In the official world, scientists keep things quiet. They release neutral statements. They talk about ongoing analysis. They say the words probably natural again and again. But behind closed doors, they're worried. Because the dip in the light curve isn't fading, it's becoming clearer, sharper, more defined, as if whatever caused it is happening again. Night after night, the curve drops in the exact same pattern. It doesn't matter what telescope is used. It doesn't matter who is watching. The dip repeats, perfect, every time. Now the idea no one wanted to say starts to creep into the room. Something mechanical can cause this. Something with moving parts. Something that shifts or rotates intentionally. But no one is brave enough to attach that word to the object yet. Artificial. Instead, they stick to questions. Endless questions. Could it be jetting gas? Could dust be blocking the light? Could the nucleus be tumbling in a weird way? They test every model, every scenario, every natural explanation. None of them match. Nothing in the universe behaves like this. And so, slowly, quietly, something changes in the way they talk. The tone softens. The vocabulary shifts. The explanations become careful, not confident, not final, just careful, because they all feel it now, that invisible pressure building around the mystery. This object, this quiet traveler from another star system, is doing something that shouldn't be possible, and no one knows why. In the next few days, as it inches closer to the sun, the dip becomes stronger. It deepens by fractions, but they are precise fractions, predictable, consistent, almost mathematical. One scientist calls it the cleanest anomaly I've ever seen. Another quietly says, it looks like a signal. But they don't know yet, not for sure. And saying those words publicly could cause panic, or worse, ridicule. So they wait, watching, measuring, trying to find the truth in the shifting light. But deep down, every astronomer feels the same thing. This isn't just a comet passing through. It feels like a moment, a message, or maybe the beginning of a story much bigger than any of them expected. As 3I/Atlas drifts silently towards its meeting with the sun, the world waits with it, because if a simple dip in a light curve can shake the entire scientific community, then what comes next could change everything we think we know. And the question hangs heavier than ever. What force is shifting the light before it even reaches the sun? Some stories don't start with a sound. They start with a silence, a strange, heavy silence that feels almost intentional. And for the astronomers watching 3I/Atlas drift through space, that silence becomes impossible to ignore. Because every night, as the sky turns dark and the telescopes open their cold eyes, the same thing keeps happening. A tiny change in brightness. A dimming so gentle it almost feels like a breath. Then, a soft return to normal. At first, it seems harmless, just a flicker on a graph. Nothing to lose sleep over. But then, it happens again, and again, and again. Same timing, same shape, same curve. A rhythm starts to form. Not chaotic, not random, but clean. Too clean. Imagine watching a star blink, not because of dust or distance, but because it wants to. That's what this feels like. Across the world, from mountaintop observatories to frozen research stations nearing sunrise, different teams begin to see the same strange cycle. a repeating pulse of light coming from 3I/Atlas. And every time they see it, the room grows quieter. Because nature doesn't do this. Space is messy, wild, unpredictable. But this is slow, steady, controlled. As the nights pass, the data becomes sharper, almost like the object is adjusting itself, fine-tuning the brightness the way someone might tune a signal. Scientists double-check their instruments. They clean the lenses. They realign the sensors. But nothing changes. The pattern stays perfect. One astronomer in Chile writes in her logbook, "It feels like something out there is blinking at us." She doesn't show the page to anyone, not yet, because she knows how it sounds, but she isn't alone. On the other side of the world, a young researcher compares 6 nights of data, lines them up, and sees something he can't explain. Each pulse matches the last. Same length, same drop, same return. He leans back in his chair, staring at the repeating dips. For a moment, he forgets the numbers and sees something else. A code, a rhythm, a message drawn in light. He deletes the thought before writing his report. No one wants to be the first to say something crazy. Not about an object from another star, but that idea, that quiet, dangerous idea. Everyone feels it. Because now the pattern is too exact to ignore. Even the senior scientists, the ones who've spent decades studying comets, light curves, and the messy behavior of old ice wandering through space, begin to stare a little too long at the graphs glowing on their screens. One of them gently taps the glass, like she's trying to wake the comet up. Another sits with his hands folded, whispering under his breath, "This can't be natural." Still, they hold their tongues, because there's one word no one wants to say. A word that can ruin careers and start panic. A word that has never been used seriously in the study of a celestial object moving through the solar system. Artificial. No one says it out loud. Not yet, but everyone is thinking it. As the pulse continues night after night, something strange happens to the people watching it. They start timing their shifts by the dips, waiting for them, expecting them. Some even grow nervous if the curve arrives a few seconds late. It's almost like they've formed a relationship with the pattern. Not emotional. Not spiritual. Just a quiet, shared understanding. Something out there is doing something predictable. Something purposeful. On the 7th night, a new observatory joins the watch. A small one, sitting alone on a plateau under a sky so clear the stars look like grains of silver dust. They point their telescope toward 3I/Atlas, expecting nothing unusual. But then they see it, the same pulse, the same drop. And when the second cycle hits, they call the main research team. Their voice shakes a little. "This is real," they say. "It's not an error. It's not our equipment. It's the object." By now, dozens of observatories across Earth have recorded the same pattern. Independent teams, different hemispheres, different conditions, all watching one interstellar traveler behave like it's following rules. Rules nothing in nature has ever obeyed. The community grows tense. Emails fly back and forth. Graphs stack on graphs. And still, the dips keep coming. Slow, steady, unbroken. One researcher compares the pattern to a heartbeat. Another compares it to a rotating beacon on an airplane. A third says, "It feels like counting." And when he says that word, everyone goes quiet. Counting. Like something is keeping time. So the scientists try to break it down. They check rotation theories, thermal models, dust shedding patterns, jet activity, phase angles, reflections off broken surfaces. But every explanation falls apart the moment the curve repeats again. Too precise, too controlled, too calm. It's like watching a lighthouse in the middle of an ocean no one has ever crossed. A signal with no sound. A message without letters, just light, appearing and fading in a rhythm too perfect to ignore. By now, nobody is laughing, nobody is brushing it off. The silent pattern has turned the entire scientific world into a field of whispered conversations. Late at night, in empty observatories with screens glowing against the walls, young scientists ask the questions their mentors won't touch. What if it's not natural? What if it's something built? What if it's trying to do something we don't understand? But the most haunting question, the one no one can shake, is this. Why would the simplest traveler in the universe, a cold object from another star, blink like it's following rules? Why would it speak in silence? Why would it choose this moment, this place, this sun, to show a pattern at all? As the data adds up, night after night, one truth becomes harder and harder to ignore. Nature doesn't repeat itself this perfectly, not without a reason, not without a force behind it. And if that force isn't random, if it isn't dust or heat or rotation, then something else is shaping the light that reaches us. Something hidden inside the object. Something that's just now waking up or revealing itself to the world. No one knows what the next cycle will bring. No one knows when the pattern will break. But one thing is clear. This is not a comet behaving normally. This is something different, something intentional. And soon, the world will see the next sign. There are moments in science that feel quiet at first, almost too quiet. Moments where the universe doesn't shout at us, it whispers. And when 3I/Atlas reaches the ecliptic, the invisible plane where all the planets move like dancers following a perfect path, something begins to whisper back. At first, it feels like nothing, just another night, another stream of data flowing across screens, another lonely shift under a cold sky. But then a pulse appears, a soft rise, a gentle fall. Clean, steady, smooth. One scientist stares at the line on his monitor and holds his breath. Because this pulse doesn't look random. It doesn't wobble or shake like normal space noise. It looks alive. The timing is exact. Too exact. Every few minutes, the brightness of 3I/Atlas rises in a sharp, perfect spike, then drops back to normal like a machine resetting itself. No comet in recorded history has ever done anything like this. And the strangest part? The pulse begins exactly as the object crosses the ecliptic, like it's reacting to the moment, to the position, to the invisible map of our solar system. It's as if something inside it knows where it is, and that idea alone chills the entire room. Hours pass. More pulses come. Each one lands at the same exact interval. No drift, no error, not even by a fraction of a second. The data looks like a heartbeat drawn by an engineer instead of nature. Slow, calm, intentional. One astronomer compares it to the tick of a metronome. Another whispers that it feels like a clock. But then he shakes his head, because that's the kind of thought that gets you laughed out of conferences. Still, the thought lingers. What object from another star system carries a clock? As the night deepens, more observatories start joining the watch. Some in the desert, some in the mountains. some perched on icy ridges where the wind sounds like a distant roar. They all record the same thing: a repeating brightness spike, same timing, same strength, same rise, same decay, a universal beat in the middle of empty space. Scientists begin checking everything: equipment calibrations, atmospheric interference, lens dust, sensor drift. Nothing changes. The pulse remains, almost like it's ignoring them, almost like it doesn't care who's watching. Soon, people start gathering around screens, not because they have to, but because they can't look away. It's mesmerizing to see something so cold, so distant, so ancient, act with such perfect rhythm. A senior researcher, someone who has studied comets for 40 years, finally breaks the tension in the room. He folds his arms, stares at the glowing graph, and whispers, "Comets don't keep time." The words hang there, heavy and unsettling, because he's right. Everything natural in the universe drifts. Stars flicker, asteroids wobble, even planets slow down over millions of years. But 3I/Atlas, it pulses like a machine with a purpose. A young intern sits at the far end of the room, eyes wide, hands shaking just a little. He's been staring at the data for hours and finally speaks up. This thing, he swallows. It knows what it's doing. The room goes silent. No one argues. Because deep down, every person watching that line move up and down feels the same quiet fear. They are witnessing something that shouldn't be possible. As the object drifts farther along the ecliptic, the pulse grows stronger. Not in brightness, but in clarity. The rise becomes sharper. The fall becomes cleaner, like the object is honing the signal, sharpening it, perfecting it. Some begin to think of it as a beacon, a light that switches on and off with purpose, sweeping across the solar system like a slow, silent searchlight. What is it searching for? Who is it searching for? No one knows. But the pulse keeps coming, time after time, beat after beat, as if 3I/Atlas has woken from a long sleep, stretching its arms across the sky, quietly announcing its presence. A few researchers try to match the timing to known cosmic cycles: planetary orbits, magnetic field waves, solar rotation, but nothing fits. Nothing in our solar system pulses this slowly, this consistently, with such perfect spacing. Whatever this timing is, it doesn't belong to us. One astrophysicist sends a message to a colleague far away. It's like someone designed it. She deletes the message, then rewrites it, then deletes it again. Because how do you admit something like that? The pulse continues. And with every cycle, the same unsettling question grows louder. If this is a signal, who or what is sending it? Hours turn into days. Scientists stop sleeping regularly. Coffee cups stack up beside laptops glowing blue in dark rooms. Everyone is doing the same thing, staring at the rhythm, trying to break it, trying to prove it wrong. But the rhythm doesn't break. Instead, it becomes part of the conversation around the world. Online forums start calling it the interstellar heartbeat. Some journalists call it the ecliptic pulse. People who don't even care about astronomy begin asking questions. Why is it pulsing? Why now? What changed? And what does it mean? A famous researcher gives a cautious interview. He looks tired, like he hasn't slept in days. He says one sentence that spreads everywhere. If this isn't natural, then we are looking at the oldest machine we've ever found. The clip goes viral. But the scientists watching the object aren't thinking about fame or fear. They're thinking about the clock, the perfect timing, the steady rise, the sharp fall, a rhythm that knows exactly where it is. Because nothing natural carries a clock across a star system, not for millions of miles, not for years or centuries, or whatever journey this object has taken to get here. But 3I/Atlas does. As it moves farther beyond the ecliptic, the pulse changes one last time, a small shift in timing, barely noticeable, but clear enough to send a ripple through every observatory on Earth. It's the first break in the pattern, a hint that something inside the object has switched modes, or woken up, or begun listening. No one knows what comes next. But the pulse has done its job. It has turned a wandering rock into a mystery into a threat, and a threat into something that feels almost alive. And as the object continues its silent path through our sky, one question refuses to fade. What kind of traveler from another star carries a heartbeat so perfect it feels like a clock? There are some moments in science that feel like the universe is playing a trick on us. Moments where the data doesn't just break the rules, it almost laughs at them. This moment begins on a quiet morning inside a small control room filled with humming computers and tired eyes. A team of researchers is watching the thermal feed from 3I/Atlas, the interstellar traveler that has refused to behave like anything we've seen before. And then the impossible happens. The object warms. Not slowly, not naturally. It warms in a sharp, clean jump, like someone flipped a switch. At first, the scientists think it's a glitch, a calibration error, maybe sunlight reflecting in a weird way. But then the object cools just as suddenly. A drop so smooth, so perfectly timed. It looks less like nature and more like a machine adjusting itself. The room goes silent. Everyone leans in, eyes wide, hands frozen above keyboards. Because comets don't do this. Nothing in space does this. In the vacuum of the cosmos, objects heat up when the sun touches them, and they cool when they move away. There is no in-between, no judgment, no control. But 3I/Atlas is not following the rules. It warms, it cools, it holds, like it's choosing a temperature, like it's comfortable now. One scientist whispers under his breath, almost afraid to say it out loud. It's regulating itself. The words hang in the air, heavy and impossible. Because temperature control is not something a rock does. It's something a living thing does. It's something a device does. Something built. But the thermal camera doesn't lie. The heat stays stable. Not rising. Not falling. Just holding. Like a calm heartbeat drawn in red and gold stripes across the screen. Someone checks the solar radiation model. The numbers don't fit. Another runs a thermal simulation. It collapses instantly. A third scientist simply leans back in his chair, staring, as if the universe has just revealed a secret too big to understand. Outside the building, the world goes on with its normal noise. Cars, voices, wind. But inside, reality has shifted, because only one question matters now. What kind of body controls its own temperature in the vacuum of space? Hours pass, and more teams join the observation. From Europe, from Asia, from North America. They all see the same thing, the stable heat band, glowing like a quiet line of fire running along the object's side. A band that stays constant even as the comet approaches the sun. That's the part that scares everyone. As 3I/Atlas gets closer to the heat of our star, the temperature should spike. Ice should break. Dust should explode into a tail. The surface should become chaos. But instead, the heat band stays calm, like it's ignoring the sun, like it doesn't care about the radiation pouring across space toward it. Temperature graphs fill screens around the world, all showing the same impossible truth. Something inside this object is controlling the heat. Something is adjusting it, holding it, protecting it. A researcher in Japan studies the pattern and notices something even stranger. The warm band doesn't behave like a single patch. It moves. Not far, not fast, just a small slide across the surface, like a light shifting behind frosted glass. She calls her supervisor. "It's repositioning," she whispers. The word echoes down the hallway, where a group of graduate students are staring at their own screens. The heat moves again. A small shift, barely noticeable, but enough to confirm the truth no one wants to face. This object is not responding to the sun. It's responding to itself. More observatories confirm it. The warm band tracks along the object's rotation, like it's searching for balance or hiding something beneath the surface. One senior astrophysicist, a man who has spent his entire life studying the cold, predictable language of comets, finally breaks. He rubs his forehead, staring at the data. "This is behavior," he says, "not physics." No one disagrees. Because at this point, the object isn't just unusual. It's intentional. It feels like something inside of it woke up. Something that understands heat. Something that needs it. Something that knows how to control it. And that idea spreads through the scientific community, like a quiet, growing storm. Late at night, in a dark office lit only by a computer screen, a young researcher writes a private note he knows he shouldn't keep. It feels like a system, a real system, with purpose. He deletes it, then retypes it, then deletes it again. Because saying those words out loud, admitting that something alien might be regulating its temperature, that would change everything. As the object moves even closer to the sun, the world watches with a kind of shared, breathless tension. Will the heat band break? Will it lose control? Will it finally behave like a normal comet? But instead, something else happens. The heat strengthens, not everywhere, just in the band. A sharp, thin line of warmth glowing through the sensor, stronger than before, like a metal coil heating under power. Theories start flying. Some say it could be reflective materials. Others say internal pockets of gas. A few whisper about reactors, engines, machines. But every theory has the same ending. Nothing natural does this. As the hours pass, the temperature holds, steady and calm, while the rest of the surface stays cold. Too cold. It's like the object has two personalities, one silent and frozen, the other warm and controlled. One observatory releases a quiet internal memo. It looks like an artificial thermal system. The words are cautious, delicate, wrapped in academic phrasing, but everyone knows what they really mean. This is not just a comet passing through. This is something designed, something with a function, something with a goal, something that needs to stay alive, or at least operational, as it crosses the violent heat of our star. And as the data stabilizes, one final realization settles in, colder than the space around it. If this object can control its own temperature, then it can change other things too. Its movement, its structure, its behavior, its purpose. What began as a quiet jump in temperature has now become a doorway, a glimpse into something we were never meant to understand, something built far from here, built for a journey we cannot imagine. And as the object drifts closer to its encounter with the sun, one question grows heavier than all the heat in the sky. What kind of traveler from another star decides how warm it wants to be in the cold vacuum of space? Sometimes the truth doesn't appear in a dramatic flash. Sometimes it appears in a single pixel, a single frame, a moment so quiet you almost miss it. This moment begins with light. Not much, just a thin streak of sunlight brushing across the surface of 3I/Atlas as it rotates in the cold dark. The object is still far from the sun, but close enough now that its dusty skin begins to shimmer. And then, something strange happens. A spike, a sudden jump in reflectivity. Bright, sharp, unmistakable. A flash so clean that one scientist thinks his monitor is broken. He taps the screen. Nothing changes. He zooms in. The light remains. And under that light, he sees something impossible. A shape. A flat, geometric patch. Too straight, too perfect to be natural, glints from beneath the dust. At first, no one believes him. They call it a glitch, a cosmic ray, a processing error, because comets are messy, rough, chaotic. They don't have straight lines. But then the object rotates again, and the patch appears a second time. Clean, bright, sharp-edged. The room goes quiet. Researchers gather around the screen, staring at the strange pattern forming beneath layers of ancient dust and ice. It doesn't look like rock. It doesn't look like ice. It looks like something made. As the object spins, more patches come into view. Fragments of a larger structure, arranged almost like panels, flat, ordered, intentional. A young intern, barely 3 months into her research role, whispers, "That's geometry." The lead scientist doesn't respond. He just leans closer, eyes locked on the shimmering shapes emerging from the surface. Because in the language of the universe, geometry is a signature. Nature curves, nature breaks, nature fractures. But straight lines, parallel edges, flat surfaces, those are rare, those are special. Those are signs of design. As the object completes its slow rotation, the patches flicker like pieces of armor catching the sunlight. Each one appears smoother than anything a comet could carry across the stars. This is not debris. This is not dust. It feels like seeing the chest plate of a ship buried under dirt for 1,000 years, finally catching the light. Yet, even now, scientists resist the idea. It's an artifact from another object. Maybe it collided with something. It could be a reflective mineral. But the pattern grows sharper, cleaner. Every time the object turns, more patches align. More edges line up. More panels form a network across its surface. A pattern no one can ignore. Observatories across the world start comparing the images. They overlay one rotation's data onto the next, and the truth becomes clearer with every frame. The shapes match, the angles stay consistent. The geometry repeats. Not random, not broken, connected. It looks like an outer shell, a skin, a hidden layer beneath the dust, waiting for the right angle of sunlight. One thermal specialist notices something even stranger. The reflective patches match the warm band from the previous chapter. Where the heat is controlled, the reflectivity rises, as if the two systems are linked, as if they are parts of the same mechanism. A murmured voice breaks the tension. Is something under the surface, responding to the sun? The question sends a ripple through every research center watching the data. Because if the answer is yes, if the object is responding, then something inside it is awake, or aware, or functioning. Teams begin running independent analyses. Some try to simulate dust movement. Others attempt to model sunlight bouncing off frozen pockets. Every model fails. Only one theory fits the data. The reflectivity is changing because something beneath the surface is adjusting itself. A panel, a shield, a part of a structure, a mechanism responding to heat. Soon, the scientific community splits into two camps. One camp says it's just a strange mineral deposit, something rare but natural. The other camp says the words, "No one wants to say." It looks engineered. But then, the object rotates again, and this time, the light reveals something new. Two of the reflective panels line up perfectly, forming a straight seam. A clean, unbroken line cutting across the surface. Everyone watching gasps. You don't see seams on natural objects. You see cracks, fractures, jagged edges. But a seam, that's technology, and it gets even stranger. As the sun's angle changes, the seam shifts, not because of dust, not because of rotation, but because the panels themselves darken slightly, like shutters, like adjustable tiles, like pieces moving. A data engineer runs a contrast analysis. He highlights the shifting pixels. A faint gasp escapes the room as the truth appears in front of them. The panels respond to sunlight. They brighten, they dim. They shift, like they're trying to regulate light or protect something underneath. Or perhaps reveal something in stages. Scientists who once laughed at the idea of alien machines now say nothing, because nothing about 3I/Atlas acts like a rock drifting through space. It acts like a device waking up. One astrophysicist, known for being skeptical of everything, quietly writes in her notebook, "It feels like the dust is a disguise." The idea spreads quickly. What if the dusty shell isn't the real surface? What if the object has been hiding something beneath its skin? Something that sunlight is now helping uncover. As hours turn into days, the reflective patches grow brighter. The geometric network becomes clearer. The panels start forming shapes that hint at structure, circular patterns, straight alignments, grids. Things comets do not have. One image finally breaks the silence. It shows 3 panels arranged in a perfect L shape, too deliberate, too clean, too precise to be natural. A design. The lead scientist slowly exhales. "This is not a surface feature," he says. "This is part of a system, a mechanism, a machine." The object continues rotating, and with every turn more of its secret face emerges from the shadows. The world watches with a kind of fearful fascination, caught between awe and disbelief. Because if these panels are real, if they belong to a structure, then 3I/Atlas is not a comet passing through our solar system. It's something built, something that traveled across stars, something that chose this moment, this angle of sunlight, to reveal the first pieces of itself. And as the panels glow brighter, as the geometry sharpens, as the seams tighten like living metal, one question rises above the rest. If something under the surface is responding to the sun, then what, exactly, is waking up inside this object? Sometimes the biggest mysteries don't come from new data. They come from old data, the kind we thought we already understood. And in the story of 3I/Atlas, the truth begins not with what the object is doing now, but with what it did before it even reached us. It starts when a junior astronomer, someone barely out of graduate school, decides to look back at the earliest readings, the data from when 3I/Atlas first entered the edges of our solar system, far beyond Neptune, far beyond the noise, far from anything that could affect its path. He doesn't expect to find anything. He's just double-checking numbers. But then he sees it, a bend, a turn in the trajectory, a course correction. At first, he thinks he misread the file. He reloads it. Same bend, same impossible shift. He calls over a colleague, then another. Soon an entire room is staring at a graph glowing in the dark. A graph that shows something no comet has ever done. Because normal comets drift. They wander on long, gentle curves, shaped by gravity and time. But 3I/Atlas didn't drift. It adjusted, a small but perfect turn, like the tiny nudge you'd give a steering wheel. And when the astronomers run a simulation backward, the truth hits them like a cold wave. The object didn't fall into our solar system. It aimed for it, like a stone thrown with intention. Like a traveler choosing a destination. Like something following a map we cannot see. The room fills with a soft hum of whispers. How did it turn? What force could have redirected it? There's nothing out there. Nothing that strong. One scientist shakes his head slowly, almost afraid to speak. This wasn't gravity. That sentence cracks the silence wide open. Because if it wasn't gravity, what was it? Everyone knows the unspoken truth. To change direction in the cold edge of space, where no planets pull, where no stars tug, you need energy. You need force. You need control. Exactly the kind of control no natural object has. No ice ball, no rock, no wandering relic of a broken star. Only one thing makes course corrections across light years: a craft. But no one says that. Not yet. Not officially. Instead, they keep digging deeper. More teams join the reanalysis. From Europe, from America, from observatories buried under frozen mountains. They run the numbers again and again and again. Every time, the same truth emerges. The object deliberately shifted its path, as if targeting our sun. The shift is tiny, but exact, almost surgical. A maneuver so delicate it could only have been done with enormous planning, or with technology that understands precision at a level we can barely imagine. When the news reaches a senior astrophysicist, someone who has studied celestial motion for decades, he reads the report twice, then whispers, "It arrived. It didn't wander." That idea, those two words, they change everything. Because arriving implies intention. It implies direction. It implies purpose. And that's when the questions begin to turn darker. If it arrived, who sent it? Or what sent it? A retired researcher, someone who has seen patterns in gravity his whole life, prints out the trajectory and pins it to a board. He draws the curve slowly with his finger, watching how it bends towards the sun, like a falling leaf caught by an invisible hand. No natural body has ever corrected like this, he says. He circles the small bend, that tiny moment where the universe shifted just a little too neatly, and he feels his stomach tighten, because that bend suggests intelligence, and intelligence suggests origin. But where? The object came from the direction of a sparse patch of a sky, a place with no nearby stars, no known systems, nothing to send anything. But maybe they're looking at it wrong. Maybe the journey didn't start near us. Maybe it started centuries ago, or millennia, or even before humans learned to write their own stories. What kind of traveler crosses the emptiness of space for that long? And why come here? Some scientists begin to theorize that the course correction might not have been a single maneuver, but one in a long sequence of adjustments, made across unimaginable distances, like breadcrumbs leading toward our sun. A trail only the object itself could understand. Others wonder if it was reacting to something. A signal, a gravity wave, a whisper from deep space we never heard. But then, one scientist, someone known for thinking in strange directions, asks a question no one is ready for. What if this wasn't a reaction, but a plan? A hush settles over the room. A plan, a planned arrival, a planned trajectory, a path carved with intention across light years. The thought is almost unbearable, because humans aren't used to being part of a plan made by something else, something older, something smarter, something that bends its own path through the dark like a hand parting water. And if this was planned, then the object knew exactly where it was going. Here, our sun, our system, our world. Soon, the data spreads through private networks, encrypted, confidential, but impossible to contain. Every scientist who sees the trajectory feels the same cold realization. This was not a mistake. This was not an accident. This was arrival. Arrival carries a weight heavier than discovery. It means intention. It means direction. It means purpose. And purpose leads to the final question, the question that no one can answer. Who or what bends its journey so precisely across light years? Just to reach us, the moment feels like the breaking of a dam. The mystery is no longer about a comet behaving strangely. It's about something that traveled to our solar system with intention carved into its very path. Something that made a choice, a turn, a decision far beyond Neptune. A decision that brought it here. And as the object continues its silent voyage toward the sun, panels glowing, heat bands shifting, pulses ticking like a cosmic heartbeat, the world realizes something unsettling. Whatever 3I/Atlas is, it didn't stumble into our sky. It came here. For a reason we are not ready to understand. Sometimes the loudest message is the one you never hear. And for the scientists listening to 3I/Atlas, that silence becomes impossible to ignore. It begins with a simple expectation. Radio telescopes across the world are pointed towards the object, waiting to detect anything. A whisper, a hum, a bit of static, even random cosmic noise. Because everything in space makes sound in its own way. Stars crackle, planets hiss, dust clouds roar like distant storms. But 3I/Atlas, it gives them nothing. Not a signal, not a glitch, not even the soft background noise that fills the emptiness between galaxies. Just silence. A silence so clean it feels unnatural. Engineered, intentional. At first, the teams think something's wrong. Maybe the receivers are broken. Maybe the calibration failed. But when a second observatory listens, and a third, they hear the same quiet void. The object isn't whispering. It isn't screaming. It's choosing not to speak at all. But then a young data analyst notices something strange. A small gap in the silence. A moment where the empty line dips, not enough to form a sound, but enough to break the perfect flatness. He zooms in. The gap repeats. Then he checks the timing, and his heart skips, because the gap lines up perfectly, with the thermal pulses from the object's surface. A pause in silence, a breath in nothingness, a rhythm hiding inside the void. He calls over his supervisor. Soon the room is filled with people staring at the same strange phenomenon. The object isn't silent. It's shaping the silence, carving it, spacing it, controlling it. Not with sound, but with the absence of sound. Someone murmurs, "It's speaking," without speaking. The idea sends a chill down every spine in the room, because silence is supposed to be random. Chaotic, a messy, natural hiss of the universe. But this silence, this one has structure. A pattern emerges. Every time the thermal band shifts, the silence dips. Every time the panels brighten, the silence tightens. Every time the object pulses with light, the silence matches the same timing. It's like two instruments playing the same hidden song. One in brightness, one in heat, one in the empty air between stars. And for the first time, scientists begin to wonder, what if the silence is the message? On the surface, the idea sounds absurd. Messages are spoken, transmitted, encoded in energy. But what if something far older or far more advanced uses a different method? What if it communicates with gaps, pauses, timed absences instead of waves? One researcher, someone known for breaking rules, writes in his notes, "This isn't a lack of signal, it's controlled quiet." Others push back because controlled silence means intent, and intent means intelligence. Still, the pattern grows clearer. Not random, not natural. The gaps in silence come at exact intervals, matching the light pulse, matching the heat band, matching something deeper inside the object that no one can yet see. Late one night, a researcher sits alone with the data. He lines up all three signals: light, heat, silence, and for the first time he sees it. A code, not one they can read yet, but a structure, a spine, a skeleton of meaning. His breath catches in his throat. He realizes something terrifying. The object chose silence, and it chose it with purpose. Maybe it's testing them, maybe it's waiting, maybe it's following a protocol older than our species. Or maybe silence is simply its native language. The next day, the world's top radio observatories gather for a private meeting. Screens glow with graphs, lines dipping, rising, falling in a rhythm that feels almost alive. Someone finally says the thing they've all been avoiding. If this is communication, then we're already in the conversation. A heavy pause falls over the room, because that idea raises a darker question. Are we supposed to reply? And if we do, what if silence means something sacred, something dangerous, something we're not ready to break? But others argue something even stranger. What if it already knows we're listening, and this silence is how it says hello? The theories spiral. Some believe the object is scanning us, using silence as sonar. Some believe it's hiding, making itself invisible to anything that listens for typical signals. Some believe it's waiting for the right moment, a key, a trigger, an alignment. But the most unsettling theory of all comes from a linguist brought in to analyze the timing of the gaps. She watches the repeated voids for hours, then says quietly, This feels like patience. Patience. A silent patience stretching across the black sea of space. A message that isn't meant to be understood yet. Or maybe one meant to be felt rather than decoded. Because the rhythm is too perfect. Too calm. Too deliberate. If this were a distress signal, it would be frantic. If it were a beacon, it would be loud. If it were a warning, it would be sharp. But this feels like waiting. Like a foot tapping gently. Like a heartbeat softened into nothing. Like something settling into place. And then another realization hits. The silence only began once the object reached the ecliptic. Meaning, it started speaking, or choosing not to speak, the moment it entered the plane of our solar system. A calculated moment, a chosen position, a decision. So again the question returns, heavier than before. Is it choosing not to speak? Or is this the message? As the object continues its slow drift toward the sun, as the thermal band hums quietly, as the panels shift beneath the dust like a creature stretching awake, the silence deepens, not empty, not hollow, structured, timed, alive, a language without words, a transmission without sound, something reaching out not with noise, but with quiet. And as researchers around the world watch the gaps widen and narrow in perfect harmony, one truth becomes impossible to ignore. We may not understand the message, but something out there is speaking directly to us, in the oldest language the universe has ever known: silence. There are moments in science where you don't just see data, you feel it. Moments that send a chill up your spine, even when the information on the screen isn't supposed to feel emotional at all. This moment begins as 3I/Atlas moves closer to the sun, closer than it has ever been in its long and lonely journey across the dark. The solar wind hits it like a storm of invisible arrows, blistering heat, raging particles, waves of radiation older than Earth itself. Most comets break under this pressure. They shed their dust in wild sprays. Tails explode behind them like burning banners. But 3I/Atlas, it reacts differently. At first, it simply glows a little brighter, like a distant star trembling awake. But then something unexpected happens. The dust doesn't explode away. It peels away, slowly, smoothly, almost gently, as if the solar wind is brushing aside a veil. Scientists stare at their screens, confused. Comets do not shed dust like this. They crack, they burst, they fracture. But this object, it sheds layers like old skin. And with every sheet of dust that lifts off its surface, something beneath begins to show. Not ice, not rock, not the rough, jagged texture they expect, but angles. Clean, sharp angles. Someone gasps, not because the image is beautiful, but because it's wrong. Nature doesn't make edges like this. Nature doesn't draw lines this straight. As the sun's heat grows stronger, more dust falls away, and the truth becomes harder to ignore. Hidden beneath the ancient layers is a structure, not rounded, not random, but shaped. Ridges rise like the spines of armor. Panels curve like the hull of a vessel. Surfaces glint like metal awakening after centuries asleep. An engineer watching the footage whispers, "That's not a comet, that's something built for travel." No one disagrees. They can't, because the shape now visible on their screens looks nothing like anything natural drifting through space. It looks like a craft, A craft wrapped in dust. A craft disguised as ice. A craft hiding in plain sight, until the sun forced its skin to come off. As more layers peel away, the true silhouette emerges. It's long, sleek, almost aerodynamic, despite moving through a vacuum. The ridges look like stabilizers. The panels appear arranged in patterns, designs, not accidents. One scientist rubs his eyes, thinking he must be imagining it. But he isn't, because cameras around the world capture the same reveal from different angles, different wavelengths, different systems. It's all the same. 3I/Atlas is shedding its disguise. The more the dust falls away, the more intentional everything looks. Solar winds carve through space like blades, scraping off centuries of debris, exposing the truth, one slice at a time. And as the fresh surface comes into view, a single thought spreads through the scientific community like a quiet fire. This is a machine. The word feels dangerous, heavy, forbidden. But no one can deny what they're seeing. Even skeptics, the ones who laughed at the idea of panels, the ones who dismissed the heat patterns, the ones who said the light pulses were coincidences, even they go silent now, because the object shape is no longer hiding behind noise. It's right there, in the open, sharp, clear, unforgettable. One researcher stares at the repeating patterns along the structure's length and says, "This thing was built with intention. It's meant to go somewhere." A wave of fear passes through the room, because built for travel implies so much more than a weird object from another star. It implies direction, purpose, destination. The question no one wants to ask begins to rise. Where was it going? Or worse, where is it supposed to go now? As the heat grows, more of the outer shell falls away, revealing darker, stronger material underneath. Something too smooth to be rock, too reflective to be ice, too engineered to be natural. Some surfaces even appear polished, curved like the outer plates of a vessel built to slip through cosmic winds. One scientist, trembling as he zooms in, notices something else. The structure isn't damaged, not cracked, not eroded, not worn down by millions of years of drifting. It looks preserved, maintained, protected by the dust shell that once hid it, like something inside wanted to survive the journey intact. The world begins to watch the unfolding spectacle with a mix of awe and dread. News outlets replay the footage. Experts try to stay calm on live broadcasts, but the truth is starting to feel impossible to contain. This is no longer a comet with strange readings. This is a machine arriving at its destination, and with every layer that falls away, another piece of its identity is revealed. One thermal analyst overlays the new images with older ones and notices something chilling. The ridges match the heat band. The panels line up with the reflective geometry. The seams align with the pulse timings. Everything is connected. Everything has a function. Everything is part of a larger system, a system we still don't understand. The machine continues drifting toward the sun, dust streaming behind it like a trail of lost memories. Scientists watch in silence, their screens glowing in dark rooms, faces lit by the shape of an interstellar traveler finally revealing its true form. Some feel fear, some feel wonder, some feel like they're watching something sacred emerge from the shadows, but all of them feel the same thing. This was never meant to be found half covered in dust. This was never meant to look like a comet. This was never meant to be mistaken for something ordinary. The reveal was always part of the journey, and now The disguise is gone. As the last pieces of dust fall away, the object glimmers in the sunlight, a dark, sleek silhouette built for movement, for endurance, for crossing the abyss between stars. A vessel, a craft, a machine older than our species, shaped by hands or minds we cannot imagine. And as the world stares at its exposed surface, one question becomes impossible to ignore. If this is a machine, then what is its purpose? A purpose now aimed directly at our sun, and whatever waits on the other side. Some moments in science feel like standing on the edge of something ancient and alive, like watching a sleeping giant open its eyes for the first time. And as 3I/Atlas sweeps past perihelion, the closest point to the sun, every telescope on Earth is turned toward it, waiting for the final piece of the puzzle. No one expects what happens next. Up until now, its light curve has been strange, unnatural, but predictable. A slow pulse, a careful rhythm, a silent pattern hiding in the dark. But the moment it rounds the sun, the light curve erupts. Lines that once flowed smoothly begin to jump, drop, surge, spike. A violent, chaotic storm of brightness that looks nothing like any comet in recorded history. It's as if someone shook the graph with both hands. At first, the scientists think the instruments are glitching. They restart them, recalibrate, switch wavelengths. But the chaos doesn't stop. The light from 3I/Atlas is moving too fast, too sharply, too deliberately. 1 second, it brightens like a star being born. The next, it collapses into near darkness. Then it bursts upward again, climbing higher each time. It looks like a system rebooting. Like something inside the object has powered on and is running through its first steps. Startup, diagnostics, activation. A researcher in Canada stares at the screen and whispers, "It's not failing, it's waking up." The world doesn't know yet, but the scientific community feels the tension rising like pressure before a storm. For months they've seen pieces, the heat band, the panels, the silence, the impossible turn. But this is different. This is not a clue. This is not a hint. This is behavior, a system behaving like it has purpose. As more data pours in, a clearer picture forms. The spikes aren't random. The drops aren't mistakes. The surges aren't noise. They follow a pattern too complicated for natural processes and too precise for coincidence. It looks like waves of energy sliding through the body of the object, as if subsystems are coming online. One by one, a propulsion system warming up. A power core stabilizing, a navigation structure recalibrating, a communication array aligning, or maybe something stranger. Something we don't even have words for. In one observatory, a thermal engineer compares the new data with the old. He shakes his head. The internal temperature is climbing, but only in specific regions, like it's activating modules. Modules. The word feels heavy, difficult to swallow, impossible to ignore. Because if this is a machine, and everything so far points to that, then the chaos they're watching isn't chaos at all. It's awakening. The brightness rises again, higher than before, as if the object is gathering strength. And then, a drop. A steep, sudden collapse into darkness that sends a shock through every lab watching. Some scientists gasp. Others lean closer. Some feel their stomachs twist in fear. Has it shut down? Has it died? Has it burned itself out? For 30 long seconds. The object remains dim, and then a single, perfect spike, sharper than anything before, tall as a mountain against the graph. A signal, a declaration, a scream into the void. Astronomers across the world freeze. Because that spike isn't just brighter than anything else. It's symmetrical. It rises and falls with exact precision, like a line drawn by an architect, not a random burst of light. One astrophysicist breaks the silence. That's not a flare. That's a response. He doesn't explain. He doesn't have to. Because everyone sees it. This spike, this perfect line, comes at the exact moment the object leaves the sun's shadow and enters full solar illumination again, as if the machine was waiting for sunlight, as if it needed it, as if the sun was the key. Suddenly, the light curve settles, not into a straight line, not into the old pulse, but into something new. A gentle, rising wave, soft, smooth, almost graceful, the awakening curve. It looks like a breath, a slow inhale after a very long sleep. Something inside 3I/Atlas has changed, something fundamental, something irreversible. The world watches as the curve continues its rise. Steady now, confident, like the object finally knows where it is and what it's meant to do. A scientist in Europe studies the curve carefully. This looks like a calibration cycle, she says. But if that's true, then this thing didn't just wake up. She turns to her team, her face pale. It came back online. Prayers back online. Two words that send a ripple of fear across every observatory. Because back online means one thing. It was offline before. Dormant, sleeping, waiting, and now it isn't. The more the curve stabilizes, the more the truth becomes undeniable. 3I/Atlas didn't wake up randomly. It woke up when the sun touched it. Like the star was a trigger, a key, a requirement for activation. But activation for what? That question fills every lab with a cold tension. Is it preparing to communicate? To move? To observe? To record? To open? To release something? No one knows. Not yet. But one thing is clear. The object is no longer silent, no longer passive, no longer hiding. It is awake. Fully awake. One researcher writes in his notes, "It feels like watching a spacecraft stretch after sleeping for 1,000 years." Another writes, "It didn't react to the sun, it responded to it." And perhaps the most chilling thought of all, it was waiting for this moment. As the final numbers settle, the curve glows on screens around the world like the heartbeat of something enormous, something intelligent, something ready. And as people stare at the data, a single haunting question echoes across every observatory. What is 3I/Atlas waking up for? A question that will only grow louder as the mystery moves toward its final phase. Some moments in science don't just break the rules. They shatter them. This one begins right after 3I/Atlas swings past the sun, past the fiery heart of our solar system, past the point where any ordinary comet would speed up as gravity flings it into deep space. But 3I/Atlas is no ordinary comet, and what it does next leaves the entire scientific world staring at their screens in stunned silence. The object slows down, not a glitch, not a measurement error, not a misreading of data. It slows down intentionally. Imagine watching a falling stone suddenly decide to stop mid-air and drift the other way. That's what this feels like. No natural object in the universe behaves this way. Not asteroids, not comets, not rogue fragments from other stars. Everything that passes the sun accelerates as it's flung outward like a slingshot. But 3I/Atlas breaks the rule. It throws the rulebook into the void. One researcher watches the velocity graph dip. He rubs his eyes, thinking he must be imagining it. He checks the calibration, checks the software, checks the gravitational model. Everything is correct. The numbers don't lie. The machine is slowing itself down. He whispers to his team, "This thing is choosing how fast it wants to go." That sentence sends a wave of disbelief across the room, because slowing down requires force. It requires control. It requires a kind of awareness no comet could ever have. And yet, the data continues to confirm it. As sunlight fades across the machine's surface, its speed drops further, not in a smooth curve like a drifting object losing momentum, but in sharp steps, almost like a series of decisions, a pause, a shift, a recalibration. Every change is clean, precise, like the adjustments of a pilot tapping controls in a silent cockpit. But this pilot is millions of miles away and may not even be alive. Or worse, it may not need to be. Across the world, scientists scramble to explain the impossible. Some stare at the velocity readouts, lost for words. Others begin to piece together a terrifying possibility. If the object can slow down, it can also speed up. Turn, aim, stop. It can maneuver. Only one kind of thing maneuvers through space on its own, a spacecraft. Yet no one wants to say the word. Not publicly, not officially, not until they understand more. Still, the evidence piles up. Every observatory sees the same curve, a drop in velocity that nothing natural in the known universe should be able to produce. A senior astrophysicist watches the graph, her heart pounding. "This isn't a reaction," she murmurs. "It's a decision. A decision." That word feels like a cold shadow moving across the room. Because decisions require purpose, goals, intent. Whatever 3I/Atlas is, it's not being pushed by random forces anymore. It's guiding itself. But why? Where is it going? And what does it want? As the shift continues, the pattern becomes even more unsettling. The object isn't just slowing down, it's changing direction. Not by much, just a fraction of a degree, but enough to catch the attention of navigators and orbital analysts. A tiny tilt, a soft curve, a correction so delicate it could only be done by something aware of its surroundings. The shift is so small that at first no one notices. Then a young orbital specialist, someone still fresh enough to question everything, raises her hand. "I think it's aligning," she says quietly. Aligning. The room falls silent. She overlays the new trajectory on the old one. The difference is minimal, but intentional. The machine isn't drifting. It isn't reacting. It's aiming. Toward what? No one knows. But the new path is unmistakable. A controlled slide into a new orbit, a new vector, a new destination. Scientists watch the updated trajectory on giant screens. Lines glow. Curves shift. Numbers pulse like heartbeats, and a chilling realization spreads. This object didn't just wake up. It didn't just reveal its true shape. It didn't just adjust its systems. It's moving with purpose, like a probe, like a visitor, like a messenger, or something far more ancient, a machine older than our species, still following instructions written long before Earth had cities, or oceans, or life. One researcher whispers, "It's not leaving, it's positioning." Another responds, "For what?" No one has the answer. As the machine continues its slow, deliberate change in speed, one thing becomes clear. Whatever it is waking up for, whatever it is preparing for, the moment is getting closer. The velocity graph dips again, a crisp, precise drop, perfectly timed. Not the hesitation of a drifting comet, the command of a system in control. The world watches with a mix of awe and fear. Some are terrified, some are fascinated, some feel a strange pull, as if they're witnessing the first step in a story that didn't begin on Earth. But all of them feel the weight of the same question. Why would any natural object change its own course in silence? The thought lingers like a haunting echo in silence. No sound, no signal, no announcement, just a shift, a decision made somewhere inside the dark shell of a machine we still can't understand. And as 3I/Atlas continues its quiet, deliberate slowing, as if preparing for something we can't yet imagine, the mystery deepens. Not with noise, not with violence, with a gentle, careful change in direction that whispers across the solar system, "I am not done yet." Sometimes the end of a mystery doesn't arrive with answers. It arrives with a question so large that it changes the way we see the universe. And that's exactly what happens as 3I/Atlas drifts into the outer dark, far past the sun, past the planets, past everything familiar. By now the world knows this object is not a comet, not a rock, not a fragment of ice from another star. It is something built, something engineered, something older than any civilization on Earth. But even machines have farewells, and this one delivers its final message in the quietest way possible. It begins when the object crosses beyond the orbit of Mars. Most of its dust shell is gone, its panels are exposed. Its structure lies bare, shining faintly in the cold sunlight. Its light curve has calmed. No more explosive surges, no more awakening pulses, just a soft, steady glow. But then, one night, something unexpected happens. A faint pulse, then a second, then a third. 3 flashes, small, soft, but unmistakably deliberate. Scientists freeze. All around the world, observatories capture the same moment. 3 gentle pulses of light, spaced with mathematical precision. Then a pause. A long pause. Long enough that the teams begin to wonder, is there more? Is another signal coming? They wait. Seconds turn into minutes. Minutes stretch into an hour. Nothing. No fourth pulse. No change in heat. No radio signal. No motion. Just silence. A silence so absolute it feels like the universe itself is holding its breath. Researchers scramble to decode it. Some say 3 pulses could mean a countdown. Others say it could be a signature, a final identification tag from a machine that has finished its purpose. One team suggests something strange. It looks like an ending sequence, like something shutting down. Another team disagrees. It's not shutting down. It's acknowledging us. But no one knows. There is no language to translate. No reference point. No origin. Only 3 pulses and a long pause. Then nothing. And the nothing becomes the most important part. In the silence after the pulses, the object doesn't brighten again, doesn't change course, doesn't produce heat. It simply drifts. Not lifeless, not dead, just quiet, like a traveler who has already delivered its message and has nothing more to say. A scientist in a dim observatory room whispers, "It's leaving." But another voice, softer, almost trembling, replies, "No, it's done." Done with what? Done with its mission. Done with us. Done with the sun. The questions pile up with nowhere to go. Because whatever 3I/Atlas was, a probe, a vessel, a remnant of a lost civilization, or something beyond our imagination, it came through our solar system with purpose. It turned when nothing should have turned. It pulsed when nothing should have pulsed. It warmed itself. It revealed its hidden surface. It awakened. It shifted course. And now it ends with 3 pulses and silence. People around the world begin to interpret the final pattern, as if it were a message meant for humanity. Some say it was a greeting, a distant wave from the dark, a sign that we are not alone. Others say it was a warning, a quiet reminder that something far older, far more advanced, has passed by and taken note of us. And some believe it was simply an echo, a leftover part of its systems running out the last line of its programming after completing a journey longer than human history. But one idea rises above the rest. 3 pulses, then a pause. It feels like punctuation, like the end of a sentence written across the background of the stars, a cosmic full stop. As the machine drifts farther away, its light dims, slowly, gently, almost respectfully, like a lantern carried into the fog until it becomes nothing more than a memory of brightness. Some scientists watch the feed even after the object has faded beyond detection, as if waiting for one more flicker, one more sign, one more whisper. But it doesn't return. 3I/Atlas is gone, leaving behind a void filled with wonder and a silence that feels almost sacred. Astrophysicists gather around conference tables with printouts of the final data. Some rub their temples, some stare blankly. Some pace back and forth, unable to wrap their minds around the simplicity and the weight of what they've witnessed. No one can agree on what the pulses meant. No one can agree on what the machine was. No one can agree on why it came. But they all agree on one thing. We will never look at the sky the same way again. Because now we know, not from stories, not from theories, not from hope or imagination, but from evidence, from data, from observation, from the cold, quiet truth delivered by a machine that crossed the gulf between stars. We know this. This was not a comet. And if it wasn't a comet, then the universe is far stranger, far older, and far more intentional than we ever believed. As the object fades into the endless night, one final question echoes across every lab, every observatory, every mind brave enough to look upward. What exactly passed through our sky, and why did it leave? There is no answer. Not yet. Only the feeling that something ancient moved past us, noticed us, and continued on its way. And perhaps the most haunting truth of all, it may not be the last one.